Welcome back to Calculus AB. Today's topic 3.2 implicit differentiation. So we have explicit functions and we also have implicit relations. So up to this point, you've learned how to differentiate functions that are expressed in an explicit form. We will now take a closer look at relations written in an implicit form. Note the differences in the two types of functions from the tables below. So you have your explicit written functions right there. And then you have y equals x squared plus 1, and f of x equals the square root of 4x cubed minus 2x plus 1. And then you have the implicitly written functions, or equations in this case. And that is x squared minus 2y cubed plus 4y equals 2, and then x times y minus 2x squared plus y cubed equals x plus y. So can you describe one of the main differences between the explicit and the implicit forms? All right, so you guessed it pretty much. In the explicit, you have y equals x squared, or f of x equals something with an x, right? So you have functions that are exclusively dependent on x. Over here, you have actually a combination of both, right? You have x and y both on the same side, right? You even have a combination of them multiplying on both the left and the right side of the equations, right? So in this case, it's not solved for y pretty much. So you have a combination of both. So let's look at the differences on how we pretty much take the derivative of these. So example 1, differentiating with respect to x, so find each derivative. So for part A, we have the derivative of x cubed with respect to x. So applying the power rule, we can find that the derivative of this is just pretty much 3 times x squared. Now, when we take the derivative of the y function with respect to x, that's a big difference right here, with respect to x. So technically, y can be any function, right? Y can be equals to 2x plus 1, right? It's just a function that is depending on x, right? It can even be y equals x cubed. It could be y equals sine of x. I don't know what it is. I know it's another function pretty much. So pretty much we kind of apply the chain rule. So here you take the derivative of y, right? So that would be 3 times y squared, same thing. And then you want to multiply it by the derivative of whatever y is with respect to x, right? So dy dx, which would be like if y was this, then I would take the derivative of this and I would get just 2, right? So I would just multiply that times 2. So here, now it's just pretty much you don't have to do the substitution because we don't know what y is necessarily, right? We can actually find out what it is later on, knowing some things. But for right now, whenever you differentiate y, right, y, you got to make sure that you attach the dy dx, right, dy dx. All right, so let's look at example C right there. So we have the derivative of x plus y with respect to x. So here, what you want to do is, again, you're going to apply the sum and difference rule. So the derivative of x with respect to x is just positive 1. So nothing changes there, right? Plus the derivative of y, right? So the derivative of y to the first power it's also 1, but then again, multiply times the derivative of dy dx, all right? Because I took the derivative of y with respect to x. So here, if you just simplify, you're just going to end up with 1 plus dy dx. All right, let's look at example D. So here we have the derivative of x times y squared with respect to x. Now, again, even though we are using, right, we do have a product there. Here we still have to use the product rule, right? So also known as the fish rule. So here you have x and y squared, right? Those are your two functions. The derivative of x is just positive 1. The derivative of y squared is 2 times y times dy dx. All right, so again, take notice that every time I take the derivative of y, I'm writing dy dx, right? So again, draw your fish right there. So you end up with x times 2y times dy dx, and then plus y squared. And that's our derivative. Alrighty. So let's look at pretty much the steps that we have to do now. So the guidelines for implicit differentiation. So first, differentiate both sides of the equation with respect to x, right? In this case, we were given simple examples. Collect all terms involving dy dx on the left side of the equation and move all the other terms to the right side of the equation. Factor dy dx out of the left side of the equation. And then solve for dy dx by dividing both sides of the equation by the left factor that does not contain dy dx. Okay, we're going to put all these steps into practice right now when we do look at example 2. So what we're going to do is, again, take the derivative of each, right? So y cubed, y squared, and then minus 5y minus x squared equals negative 4. So we're going to take the derivative of both sides, right? We draw a line here. So if I take the derivative of 3y cubed, I end up with 3y squared times dy dx, right? So let me give it a little bit more room. I need more room than that, probably. All right, if I take the derivative, so plus, I'm done with that. The derivative of y squared, that would be just 2y times dy dx. The derivative of negative 5y would be just negative 5 times dy dx. And then finally, the derivative of negative 2x squared would be just negative 2x. Again, take notice that I didn't put in any dy dx when I took the derivative of x. And then this equals the derivative of negative 4, which is a constant, so it's just equal to 0. All right, so we took the first part. First step is done. We differentiated both sides of the equation with respect to x. Now we want to collect all terms involving dy dx. So there's one here, there's another one in there, and then there's another one in there. And then we want to move all the other terms to the right side of the equation. So we have negative 2x, so we're going to add 2x to both sides. And then we have, right? So factor the dy dx. So these are pretty much the only ones that are left with dy dx. So we can bring out that dy dx. And that leaves us with 3y squared plus 2y minus 5 equals positive 2x. So we're done with that as well, right? Those two steps, and then divide both sides of the equation by the left-hand factor that does not contain dy dx. So we're going to divide both sides by 3y squared plus 2y minus 5. 3y squared plus 2y minus 5, and we end up with dy dx equals 2x over 3y squared plus 2y minus 5. And that's our derivative. So again, following the steps, we differentiated both sides here, right? That was our step 1. We collected all the terms, right? These are all the terms, right? That was our step 2. And then our step 3, we divided both sides of the equation. Actually, we factored out, right? Step 3 was factoring it out, which is what I did right here, right? All those factors right there. You can just treat like a number pretty much. Remember, it's still a slope, right? Dy dx is just a number. It's a slope. And then here we end up with dividing that. So it's our 4th step, right? And we have our derivative with respect to x of our implicit function, which is 2x over 3y squared plus 2y minus 5.